Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. For the first, let me introduce myself. My name is Kina Fitri Shawalia with ID 8231240002. Okay, now I will present my assignment from English Format Education that is about mathematics material at the high school level. And the topic that I bring is about limit of functions. Okay, for the first step, I will explain to you about our learning goals. That is, first, students are able to explain the concept of the limit of a function at a point by using left hand and right hand approaches. Next, students are able to calculate the limit of simple algebraic functions using substitution and factorization methods. And the last one is students are able to solve limit problems involving indeterminate forms in a simple manner and present the solution steps correctly. Okay, next I will explain to you about the definition. So, mathematically, the limit can be defined as follows. Here we have two definitions, and for the first one is limit as x approaches a for fx equal L. This means that if x approaches a but x is not equal to a, then the value of fx approaches L. That's for the first definition. Next, if the function fx is defined on the interval a, then for section A, limit as x approaches a for fx equal L exists if and only if limit as x approaches a from the left for fx equal L and limit as x approaches a from the right for fx equal L. For section B, if limit as approaches a from the left for fx equal L1 and limit as x approaches a from the right for fx equal L2, whereas L1 is not equal L2, then the limit as x approaches a for fx is not exist. That's for the second definition. So for this section, what I want to explain to you is if we already doing approaches from the right hand and the left hand, and we got L1 is not equal L2, then the limit is not exist. Okay, next we talk about properties of the limit of functions. Here we have 8 properties. I will explain to you. For the first one is limit as x approaches a for k equals k. For this, it means k for constants. So if limit as x approaches a for a constant, it means the result is that constant. Okay. For the second one, is limit as x approaches a for x, whereas x is a variable, then the result is a. So for this one, it was like we just need to substitution the value where, so the result is a. Okay, next, limit x approaches a for k times fx equal k times lim x approaches a for fx. So if we have this this one properties, whereas we have a constant and we have a constant in the function, we just need to move the constant to the front so that only the variable remains. Next properties. Okay, for the next properties is lim as x approaches a for fx plus minus gx equal lim x approaches a for fx plus minus lim x approaches a for gx. Next, uh, lim as x approaches a for fx times gx equal to lim x approaches a for fx times lim x approaches a for gx. Next, lim as x approaches a for fx over for gx equal to limit x approaches a for fx over for lim x approaches a for gx with n limit x approaches a for gx not equal 0. That's the rule. Next is limit x approaches a for fx to the power of n equal to lim x approaches a for fx to the power of n. And the last one is limit x approaches a and root of fx equal to n root of limit x approaches a for fx with fx greater than 0 and n is even. Okay, for okay, I already explained about the topic. So to help you all of you understand better, I will give further examples from each properties. Okay, for the first one is I have some examples. I will explain it from the first. Okay, number one, limit x approaches at 2 for 3, so the result is 3. As I explained before, uh, from the properties of the limit of function, if limit x approaches a for k, then the result is the constant itself. So the result of limit x approaches 2 for 3, whereas 3 is a constant, so we get the limit is 3, the constant itself. Okay, for number 2, limit x approaches 2 for x, we already know x is an variable, so we just need to substitution where is x where is limit x approaches at 2, so we just need to substitution x as 2 at x to 2. Okay, so we got for this limit is 2. The result of the limit is 2. Next, number 3. Okay, for number 3, lim x approaches at 2 for 3x squared. As I explained before, if we have this kind of properties, so we have to move the constant to the front so that only variable remains. So we move the constant, that is 3, we move to the front, so it remains lim x approaches at 2 for x squared. And then we use substitution x, so we got 3 times 2 squared equal to 3 times 4. So for this limit, we get the result is 12. Next examples, number 4. Okay, for number 4 is limit x approaches at 3 for x squared plus 2x equal to limit x approaches at 3 for x squared plus limit x approaches at 3 for 2x. So for this example, we just need to put the limit for each one and then we solve as usual as before. Okay, so the result for this number 4 is 15. Next, limit x approaches at 2 for x squared times x. It's same as before, we just need to put the limit for each one and then we substitution, and the result for number 5 we get min 8, negative 8. And number 6, this same as before, we just need to put the limit for each one and then substitution, and then we get the result. For number 6, we get the result is 2, and so on. Okay. Okay, before I close my present, I will give you guys one example again. Uh, as you guys can see, from all of the example is easy. We just need to substitution what x approaches to. But for this one, what if we can't just substitution the value of x? So it was like we have to factorization the function first, so after that we can substitution what x approaches to. So here's the example. uh, lim yeah let me write the problems first. Okay, this is the problems for next examples. Lim x approaches 0 for 2x plus 2 times sin x minus 2 over 4x squared minus 4. Okay. Uh, okay. So reminder for this one. I guess we all already learned about exponential. So this one we can change to x squared minus 2 squared, isn't it? Whereas from exponential, if x squared minus 2 squared, that equal to x plus 2 times x minus 2. That's why for this one it changed to this. So lim x approaches 0 for 2x plus 2 times sin x minus 2 over 4x plus 2 times x minus 2. Okay, for the next step, we just need to separate the limit. So we got lim x approaches 0 for 2x plus 2 over 4x plus 2 times, I forgot the limit. I'm sorry guys. It should be have limit here. So lim x approaches 0 at 0 for sin x minus 2 over for x minus 2. So for reminder, for the limits, if we had this one, like the shapes is it was like sin a over for a, that equal to 1. So for this one we get the result is 1. Okay, so for the limit x approaches at 0 for sin x minus 2 over for x minus 2 is 1. Okay, for this one, for this limit. So and then for this one, for this limit x approaches 0 for 2x plus 2 over 4x plus 2, we just need to substitution the x. Okay, so we change the x to 0, so we got the result is 2 over 2 times 1. So the result for this limit is 1. That's all from me. Thanks for your attention and assalamualaikum warahmatullahi wabarakatuh.